So I'm going to pick an easy example, something that you should know the answer by just looking at the circle. 7.5 is we're actually solving for something. We're not proving anything. We're solving for theta. But they're going to tell you where theta is located. Okay, so for part A, when you see 0 to 2 pi, they're talking about one period. So how many solutions do you see? How many times is cosine equal to 1/2 from 0 to 1/2, or 0 to 2 pi, going all the way around? Part B is going to be assuming you can keep going around forever. Okay, so no restriction. So all you have to do is first find part A, and then tack on a piece that will account for all the infinite solutions. Okay, so let's just go. Let's do part A. So the way I want you to think about it is use your inverses to help you out. So given this equation, do cosine inverse of both sides. This will cancel, leaving you with theta equal to. Your calculator should give you 60 degrees. Even though, so let's pretend we didn't know it was on the circle, because eventually theta is going to be or the equation will be equal to some weird number, so it won't be an easy answer. So the way you should do it is do the cosine inverse of both sides. These cosines cancel. Theta is equal to whatever the calculator gives you. So when you're doing a cosine type, theta 1 will equal the one you find on your calculator. Theta 2 will be 360 degrees minus 60 degrees. So 300 is the other solution. Okay, let me find the circle. I'll put that back in just a moment. Okay, so cosine equal to 1/2. We know the answer was 6, right? Your calculator will also give you 60. Now, the other one, you can see it is over here, 300 degrees. So you're going to find it every single time is your calculator. Right on that, then do 360 minus that. Oh, yeah, we can do it. And it depends on what calculator you have, but there should be an inverse button. Let me switch back. So that's the rule for cosine. Now, if you have like an T84 or whatever, or 83, get the glare out of there. Okay. There we go. So you should see a cosine -1 somewhere above the cosine. So just hit second cosine and should pop up your inverse function. So then you plug in the value, right? We had 1/2. And if you are in degrees, it should give you 60. So that's where this comes from. Once you have this, the second angle, this, remember I showed you there's 2 locations, do 360 minus that solution. Okay, does that make sense? It's always gonna be 360 for cosine. Let me write the rules down for cosine here. Number one. If theta 1 is in quadrant 1, then theta 2 will equal 360 minus theta 1. So it depends on the quadrants. Okay, now if theta 1 is in quadrant 2, then theta 2 is equal to 180 minus theta 1. So right here, this is the rules for cosine. Okay. So that's what we got, theta 1 and theta 2. Looks like a 0. Once you have these, part B is straightforward. Okay, at least for this one. Part B will simply be two solution sets. So the first set will be your 60 degrees plus 2K, sorry. Plus 360 degrees times K. Where K is an integer. Theta 2 would be the same thing. 300 degrees plus 360 times K. And K is an integer. The math symbols are K, epsilon, capital Z, lowercase epsilon. Some of the books use this notation to say element of, so K is an element of integers. Capital Z is reserved for integers. Sometimes they use I, but usually it's Z. I don't remember why it's Z. Anyway, epsilon. Lowercase epsilon. It's like a little e. Kind of. It's hard for me to write it. Comes out crappy. I can show you a nice picture if you like. It's like this one. Kind of like an E. So if you see that in a math book, like this one right here, yeah, they mean element of. You can write in English if you want. If you want, I'm just trying to save space. Doesn't matter. K is any integer. That's all I'm saying. Okay, so if you find the, oops, I'm not there yet. Yeah, so this right here just means K is any integer. -1, 0, 2, 3, 4. All the counting numbers, negative and positive. Yeah.
How would you do it in the bottom was
Just the same way, you'd plug in that number, whatever that is, into the calculator, and it'll give you data one. So whatever that is, you subtract from 360 to get the other one. So I picked one that was easy to see for the first example because it's clear, right? You subtract and you get the other one. But eventually, yeah, you're right. It's not going to be a simple number. Any questions on part number one, part A or part B? Okay. Turn the page in a second, then. Let me know. Let's do another one, but this time with an easy one with sine. It's also on the circle. Solve sine theta equal to 1/2. So part A will be the same. Solve for theta between 0 to 2 pi, which is the same as saying 0 to 360, right? Part B will be solve for all solutions. So if they don't tell you what, if they don't give you a restriction like this, then assume it's all of them, that you're finding all solutions. So if they don't say it outright, theta's here, then just find them the way we did here. If they don't mention the restriction, then they want this. Okay, yeah. K is just, so the reason we do it, I think it'll make sense if we discuss why. Do you agree that if I add 360, that I'll end up in the same spot? 60 degrees. Right, if I'm at 60 and I add 360, don't I end up at the same spot? You know, if I subtract 360, don't I end up back again? So no matter what K I choose, if I do it 5 times and go in a circle and end up in the same place, I'm getting another solution. So this is counting for all those times you go around and around. So there's an infinite number of, solutions if I keep adding 360. So think about it. Let me show you the thing again. Where is the mouse? Where is it? Minimize it. Here we go. There it is. So I'm trying to make sure it ends up on the recording. So if your solution is at 60 degrees, say you're right here, right? If I had another 360, I'd end up there again and again, right? I can keep going around and around forever. I can make 360 be 1,000, it could be 5, it could be 10, but you see how each time I change K, I get another one. So all solutions, so each one of those theta 1s and thetas 2 are an infinite solution set. Well, no, it would just be part of this set. So theta one makes, like if you were to write them all out, then you would write forever. So the one that we wrote right now, go back to the paper here. This takes care of each revolution. One, two, three, four. I'll have a set of answers. So if it can be any integer, then I'll have all of them that map on 60 degrees. This one will take care of every single one that lands on 300. Two sets are infinite. To cover all my solutions. But they don't restrict you. We know that we keep going around the circle forever. We'll have infinite solution no matter what. Because the sine, cosine functions and all the trig functions are cyclical, right? If we look at the graph, they repeat themselves. So the solution should be hit multiple times over and over again. So it's going to keep happening forever. That's why we tack on that 360 to take care of every single one. Okay. That makes sense, everybody? All right. So once you find the specific answers, the two angles, just tack on that 360 degrees. That's it. That'll take care of your infinite part. So part A, use your sine inverse of both sides. Well, let me write the equation first. Sine theta equals 1/2. Use sine inverse of both sides to cancel your sine and solve for theta. That's why we do this. These cancel, leaving you with theta. Now we look at our calculator. Right, let's pretend we don't know the answer. I'll put it back in a second. Second sine inverse of 1/2. It's 30 degrees, right? So this is 30 degrees. So what we want to do is say, you know what? Theta 1 is equal to 30. Theta 2, the rule for sine is going to be 180 degrees minus 30 degrees. So there's my theta 2. Okay. To part B, all you have to do is tack on that 360 K. So theta, the solution, infinite solution set for theta 1 will be 30 degrees. Yes, that's times K. Theta 2 will be 150 plus 360 degrees K. Once you find that first part, just tack it on. Yeah.
If theta one was in quadrant one, then it would be 360.
That's for only for cosine. That rule is for just for cosine. This is a rule for sine. And remember that sine inverse will only be in quadrant 1 or quadrant 4 on your calculator. So just use this. This is a rule for sine. Anyway, so that's the general idea. Eventually they're going to be uglier. Just want to make sure that first part makes sense. Do you see how you find the first one and the second one for both sine and cosine? Okay, then let's do them. Let's do some that require actual work. So example 3. Solve for theta. So notice they didn't tell us that theta is within anything, right? They just gave us an equation and that's it. 2 sine theta minus 3 equals to -5. So isolate sine and then introduce the inverse sine like we did before. Okay. So I'm gonna add the 3 over. Divide by -2, or sorry, divide by 2 rather. You get to here. I skipped the algebra steps. Is that cool? Do you see how we got to here? Let me know, and I can add more steps. So all you're doing is just like you've always done, right? Solving for x, solving for whatever. We're isolating sine theta. So the first step was +3, right? Next step is divided by 2. It gets to here. Once you're there, you bring back the inverse sine. Okay, so every single time you're doing these, the goal is isolate your trig function on one side and then bring your inverse sine. Just like this. So at that point, theta is equal to, well, let's use our calculator. -90. Where is -90? So just add 360 to adjust. It's going to be 270, right? Instead of the bottom. And then there's only one place that we have sine equal to -1. So that's it. But they didn't tell us for one period, so you have to tack on this part. So theta 1 is equal to 270 degrees plus 360 k, where k is any integer. Any questions on example 3? So the next one, we'll use a unit circle just to make it a little shorter. Right. You guys cool on example 3? So let me know. Example 4, we'll use a unit circle just because it'll be a little easier. 2 sine squared theta minus 1 is equal to 0. This time they're telling us that theta is between 0 and 2 pi, or 360. Now, I'm using degrees on purpose because the calculator gives you nicer solutions if it's in degrees. If you use radians, it's gonna be a bunch of weird decimals. Because like, how do you write 2/3, right? Unless you have a fancy calculator. Using degrees is easier for solving trig equations. That's my recommendation. Okay, anyway. This is 2 sine squared theta minus 1 equal to 0. So first thing we should do. This time I'll show the algebra just in case you guys are lying to me. You don't see it. Oops. The +1 gets us to here. Divide by 2. Gets us to here. Square root both sides, right? When you square root both sides, you have to tack on. We've been saying. The plus or minus. So sine theta is equal to plus or minus the square root of 1/2, which is equal to plus or minus 1/√2. If you rationalize this, you'll get plus or minus square root 2/2. I rationalize this so you can see the obvious solution. This is a familiar value, right? So anywhere the sign is plus or minus square root 2/2 will be the solution for theta. So just look on your circle. Theta will be equal to this set. Pi/4, right? It's positive root 2/2. 3 pi/4, it's still positive. 5 pi/4, it is negative. And 7 pi/4. Now we'll look at the circle if you don't see what I'm talking about. Just a second. This one? Okay, so we'll do that right here real quick. Remember the copy of the square root says you can separate the factor, right? Separate it, square root of 1 and 1. Then you have to rationalize. Once you do that, you get this. So square root 2 times 1. Square root 2 times square root of 2 is root 4, which is 2. That's how this comes about. Right. Now let's see where those values came from. Oh, yes. So the question, once we got to the final part, we had sine theta equal to plus or minus root 2/2. Once we rationalize, where sine root 2/2, where it's here. Here. There and there, right? We had 4 answers. Positive were pi/4 and 3 pi/4. The negative were 5 pi/4 and 7 pi/4. Using the circle, we can just write them all down because they said from 0 to 2 pi or 0 to 360. That's where these came from. Okay,
How do you know which ones to choose?
which one's what?
Like the negative one, or that's what a lot of people say. So you're looking for negatives on that.
That's because of the plus or minus. When you square root both sides, we had to deal with the plus and the minuses. If it wasn't squared to begin with, we would have had only we wouldn't have had a situation. We would not have had 4 solutions.
So we're looking for.
Yeah, so the question is, when is sign square root 2 over 2, or when is sign negative square root 2 over 2? So you have four locations. Okay, any other questions on number 4? Is it okay? No, let's do something more difficult. So let's say they change the range. Instead of 0 through 60, they say 0 to 720. So there'll be, so you go around the circle again and find another 7. Okay. You guys cool on this page? Solve cosecant theta equal to -2, where theta is between 0 to 720 degrees. So do you agree that it's two revolutions, right? When around 2 times. Okay, so first thing is solve for theta, and then we'll deal with this. So cosecant theta is equal to -2. You agree that this is the same as saying 1 over sine is equal to -2, right? So I take the reciprocal of both sides, or if you want to do cross multiplication, I don't really care. You'll end up here. If I flip over both sides. That cool with everybody peer to here? Once you get there, well, that's not another let's look at your unit circle, right? We know where that's at. Where is sine equal to -half? Bottom half for sure. So 210 and 330, right? So the first angle would be 210 degrees. The second one would be 330. Is that right? Yeah. So look at your circle and you'll find those two. So, but we have to now deal with the 720 thing. Okay. So if I add 360, this one, I'll still be below 720, right? Let's go around one more time. Land here. Same for that guy. At 360 will go all the way around. Land here, but still be within 70. That's what we're trying to do. So theta 3 would be 210 plus the 360, which would give us something, I don't know. What is that? 570, is that right? Theta 4, same deal. Add 360.
Same.
690. So we have four solutions. The original 210, 330, 690, 570. So if you prefer a solution set, you would say 210, 330, 570, 690. But either way, same thing. Does that make sense? Because we were allowed to go around again. That's why we had another 2.
And for
Because
instance, if the board has 720, then put it on.
right, so like you had another, let's say it was like 900 degrees or something. You had another 360 to land on that same spot, but you end up beyond 900, then you would not include it. Okay, so you have to obey this restriction. Okay. That makes sense. Also, I cannot subtract 360 because that would give us another solution. But it says it has to be above 0. That's why I didn't use any negatives, negative angles. All right. Now let's do a couple of examples where they are not on the circle and we just have to deal with it. You guys cool on number 5? Okay, just let me know. I think I can fit it in here. Okay. So you would start, right, by doing a sine inverse of both sides. But notice how I no longer have a nice value on the right-hand side here. So I have to use a calculator. It's just how it goes. Second sine inverse of 0.8. In degrees, it'll be 53.13. We'll round to 1 decimal place. If I don't tell you in the exam, just 1 or 2 is fine. Okay, I'm not gonna, again, like I said, we're not building anything, so it's okay. If we were in chemistry or physics, it would be important to remember significant figures. But we're not doing experiments. We're building spaceships. So theta would be equal to 53.1. Yeah, we're doing math for the sake of it, for fun. Okay, so 53.1 degrees. So the rule said, a while back, that's the first one. Theta 2 is equal to 180 degrees minus 53.1. This is the rule for sine. So the other angle is 126.87 degrees. If they don't tell you 0 to 2 pi, you're gonna have to use that rule. 53.1 plus 360K, and 126.87 degrees plus 360 K. Any questions on that? You know, it's the same thing, right? It's just that you have a weird number and you can't use a circle. Quite a few examples. I'm trying to cover each type that you might see on your homework. There's just a lot of, there's a lot of them. Okay, let's do one with cosine that's not on the circle. So we did sine one. Let's do another cosine type. You guys cool on example 6? Any issues? Okay. They didn't tell us a period, so let's assume that you will have to tack on that infinite piece. Secant theta equals -4. So use your reciprocal property. That will be cosine, right? Flip them both over, upside down. Get to here. Now, the actual technical rule that I use is I'm taking the reciprocal of both sides. And flipping something over is not an actual math operation. It's the reciprocal of both sides. Or in other words, the -1 power both sides. But if you prefer cross multiplication, you could do that here. But I think this is easier. So at this point, use your calculator. What is cosine inverse of -1/4? Make sure you are in degrees.
And
75.5. Okay. For -1/4, right?
yeah, I put -4 as error.
Oh, make sure you use on your calculator this negative symbol. Do not use subtraction symbol for functions. You will get an error.
Oh,
So it should be 104 point. We're on to 1 decimal, I guess. Cosines cancel. We end up with 104.5. Although I think that you got one of the solutions. The other one is going to be, we said, if we are in quadrant 2, theta 2 is equal to 180 minus that solution, which will be 75.5, which is what you got, right? So we need to add the infinite part. For both of them. And we're done. Any questions on this example?
Rebecca 180 was just for sine.
We had 2 rules for cosine, and it depended on what,
Oh,
if we were in quadrant 2. Or 1. For sine, we only have the one rule. So the first few examples will be just like this, just doing basic algebra to solve for sine, cosine, secant, whatever. Just change it to something you know, introduce inverse, and find both sets, okay? They may or may not be infinite. On your exam, there will be one or the other, or both. The homework, I don't know how they ask it, but just remember, I'm gonna ask for something like this, or I might just ask for this one right here. Okay. If I say 0 to 5, then you're going to do this. If I don't say anything, or if I say all solutions. Yes. Okay. All right. Any questions on 7? All right. Let's do 2 more if we have time, maybe 3. Let's see. Yeah, that's fine. Okay, so sometimes you'll have tricky equations that are in quadratic form. So you'll have to factor like you did back in basic algebra or college algebra. You know what I'm talking about? You have some polynomial equal to 0, and then you would factor. Same thing. It's just that you have cosines. And then sometimes you have to use quadratic formula, which sucks. Let me pick an easy one first. Oh, that's too simple. Yeah, that's an easy one. Hopefully, I'm always hesitant to make some up on the spot because sometimes things go horribly wrong, but we'll see how it goes. So let your cosine equal to some dummy variable. Let's call it W or X or something. Let cosine theta equal X. So that would change this equation into x squared plus 6x plus 5 equal to 0. Right? So at this point, it's something you've seen before and you solved many, many times. So solve for x. We should know that solving all quadratics requires factorization or quadratic formula. I chose this one because it should factor nicely. Right? Do you agree with that factorization? Okay. And then the way you would solve it, you would set each factor equal to 0 and solve for x. Just in case you forgot, it hasn't changed. So x is equal to -1, x is equal to -5. But x was made up, so we got to change it back to cosine. That's what we really want. That makes sense? Once you're here, what is wrong with this equation over here? Can you spot it right away? Will this ever be true? Why or why not? Well, it can be -1. Yeah, remember if the unit circle says it's a unit, right? So it has to be 1 or -1. How can it be -5? That doesn't happen. It's never gonna happen. If you try to do the inverse of both sides, you'll see it. Let's pretend you didn't catch it. Right? I'm sure you all caught it, but let's pretend. You're gonna get an error. The domain error meaning it's outside the domain. Okay. So this has no solution right there. So you don't have to do any work. Move on and focus on this guy. When is cosine equal to -1? We should know that it's on the circle, right? Yeah, it's going to be pi. So theta is equal to pi. But we got to add our 360 part. I should say 180. If I'm going to use degrees, 180. But if you're using radians, you would have to add 2 pi k. Okay, same thing. The homework might give you one or the other. But so you'll have these type. So if it helps, just change it and then factor and then change back. Just remember that you might get some that require quadratic formula, and those are annoying. Any questions on number 8? Okay.
So is no solution because that is not correct?
There's no solution because cosine will always be within 1 and -1.
Okay, so that stops there.
Yeah, like if you graph it, the highest it ever gets is 1, and the lowest is -1, so it will never get to -5, no matter what angle you choose. So that means there is no solution. And if you try to solve it, you'll get an error.
So that makes it like you won't find -5, which is why it's.
Right, right. Yeah, there is no x value that's -5. Any other questions on number 8? Okay. Let's do one more. This time we'll force the type of stuff I don't like. I'm gonna skip some steps because it's a lot of space otherwise. Is everyone comfortable with the quadratic formula? Assuming they beat you with it in high school, right? This time I will require a restriction. So let x equal to cosine. That means we have x squared plus 3x minus 1. There's no way you can factor that. So use a quadratic formula. Right? So our x will equal -3 plus or minus the square root of 3 squared minus 4 times a times c all over 2 times a. So that'll be what, nine minus plus 4, right? Which is 13. So x is equal to -3 plus or minus square root 13 over 2. Actually, let's separate them. Let's do a plus first and a minus first. Second, sorry. Okay. On the next page, I'm going to switch to cosine. Ran out of space. Are you guys cool with the quadratic formula? Any step that bothers you? Okay, so on the next page, change the axis to cosine equal to those two things. Wait a second. That's cool if I turn the page. Right. No, it's a lot of problems, but we're almost done. Promise. So we're at cosine theta. Try and do one of each type, and there's many different types. So when you get to this point, you should check and see how big are these numbers? Because if they're less than -1 or bigger than 1, then we can say the same thing we said last time, right? We said no solution. So what is this as a decimal? What is -3 plus root 13? I have no idea. Point, what?
All you want to see is 2, right?
Yeah, I divide by 2. I'll do it with you to double check here. If you have this calculator, you can press alpha and then y equals to create a fraction. If not, put parentheses and then /2. Do it again. Go with a minus. Yeah, you see the issue with this one, right? This guy has no solution. All right, that's not a degree. So there's no solution here. This one does have a solution. So that's the only reason I changed them to decimals. Although I don't want to use inverse on this guy. I want to use inverse on this. Because this is an exact number, this is an approximation. So what I want you to do is do cosine inverse of this guy. That'll be slightly more accurate than using this. So theta, I'm skipping a step here. Cosine inverse of both sides will give us 72.38 degrees. So we only have one. So that's the first one. Theta 2 will equal. The rule for cosine was 360 minus 72.38. So the other one will be 287.6 degrees. Any questions on number 9, I think it was? Is it okay? Is it weird?
This one we saw as well, but and the last one we stayed.
The last one, why we didn't do it here?
Because that one was that one. Oh.
It's because there's only one spot for this. It goes in only -1 in that one area. You could, but you end up, it wouldn't work out. You'd end up at the same spot. You see what I mean? It'd be 180, 360 minus 180, which is again the same thing. So you could try, you should, but you'll see that it was unnecessary. Anyway, these are the two answers. And that's it. Okay. Let's see if we can get another one in here. Example 9. 2 sine squared theta plus sine theta is equal to 0. And 0, if theta is between 0 and 360. So here you could change it to x again if you want. It's not really necessary. You see that you could factor sine, right? Just factor sine out. You should be done at that point. When you get to here, we know that the rule says when you have a factor equal to 0, set each one to 0. So solve for sine here, you end up with -½ right? So when is sine theta equal to 0? That's your first angle. On unit circle, that's gonna be 0, right? When is sine theta equal to a half, negative half? As a degree, as a degrees? 10. And the other location? Should be 2 negative halves.
330.
Cool, all right. That's all three. We don't have to tack on the 360 thing because they gave us a restriction. You could have used your inverse and then just use the rules if you wanted to. But these were all on the circle, so I just decided to be lazy. Here's our three solutions. It's straight up from the circle. So find out where's sine negative half, or here, these two. You could have done the inverse on both sides, and then you would have gotten one of these, and then you do the rule for the other one. But I did not. Okay, we're just about out of time. I'm gonna leave you with the next question to work on your own, or maybe we could talk about it next time. I don't know. Solve cosine x times cosine 2x plus sine x times sine 2x equal to square root 3 over 2. So solve this guy whenever you want. Or we can talk about it next time. Let me take roll and let you guys out. Well, that is the ending for chapter 2 material. So exam will be Monday. Okay, so we're going to review Wednesday and Friday. And I'll also be upstairs Monday, Wednesday. Today and Wednesday. Sadie, Jadlin, Ava, Andre, Zoe, Aaron, Michael, Alexandra, Juan, Juliana, Epifania, Andrea, Kimberly. No, Kimberly. Okay. Diego, Teresa, Hunter, Angelica. No. Okay. Connor. Okay. I'll see you guys Wednesday. You have 3 homeworks that are still open. One closes tonight. I think another one closes Wednesday, and the last one I don't remember. But 7-3, 7-4, 7-5 are still open. Need help? I'll be upstairs at 10:15 till about 12. I'll see you later. See you guys later.